at it. Open up that. I forgot about that. Let me hit OK. Let me get rid of this. Close that out. Let's preview. And then let me see this one. That's fine. And then this one. I know I usually gotta close that out for it to behave properly. All right, I'm gonna close this. Let's go ahead and start. Okay. Let me just kind of do a little announcement. So it's no major announcements. The only real announcement. So we have exam 2 should open up tonight at midnight and be available to the end of Saturday night. Should close out Saturday 11:59. You can actually work on any assignment past the due date with a 10% late penalty. So that should still be in effect for this assignment as well. And today we're going to focus on section 1.4, right? So let's hop over to Pearson and go ahead and focus on section 1.4. You guys is going to be here. So what I've been doing all day with my classes is trying to target different questions so that to see all the questions you would need all the lectures from today, right? So for section 1.4, my first class, I just started with the first couple of questions. When we ran out of time, then that was it. My second class, I targeted a different set of questions, right? So between the two videos, you have more questions collective, right? So for you guys, I'm going to continue the same pattern. Try to pick up where I left off. I think I made it. Matter of fact, I'll just work back. No, I don't want to work backwards. I know I made it to about here. Let's start here. We can start here. Let me go to the next one because I just did this one. I think this was the last one that I did with them. I think that was the last one. Okay, we'll start with this one. And then let's do this, this. Okay. Admit. All right. All right. Let's do my paper, and I'm pretty sure I'm gonna have to reboot this. Yeah, let's just reboot it. Okay. So I'm gonna take some notes and get a copy of this, and then we'll hop over to the tablet and see what I'm writing down. Okay. So let's do paper, graph paper, and okay. So this is section 1.4, a library of functions. Okay, a library of functions. This is question number 19. And it comes from section 1.4, question 61 from the back of the section. This is centered around the difference quotient. Oh, and also I'll be monitoring the chat, right? So if you have specific questions over any questions, either from the homework or Alex or anything of that nature, just type it in the chat. If you're working in the homework, keep in mind you can always use that Ask My Instructor button, and it'll come to my email and just in the chat say, "Hey, Mr. Pfeiffer, I just requested a Ask My Instructor." I'll pull it up and we'll see specifically the one that you asked. When you use the Ask My Instructor, it shows me your numbers, so that way we can work on the same one. Yeah. But yeah, you can ask questions from the homework. You can also ask questions from Alex. We have a lot of time together, so hopefully you guys can take advantage of it. All right, so the difference quotient. Again, difference quotient, we're going to be doing f. In this one, we're going to do f of x plus h minus f of x all over h. And then our given f of x is going to be x squared plus 9. Okay. Let's hop over to the tablet and do it here. think that worked. This should have worked. Let me check. Awesome. Okay. So we're doing difference quotient, right? So the blue is the general form of the difference quotient, and we're going to apply it to this f of x, all right? So to do the difference quotient, the first thing I'm going to target is this f of x plus h. So if we just do f of x plus h by itself, so we're going to place first we're going to replace each x with a blank set of parentheses. And then into the blank parentheses is going to go this guy, the x plus h. This one. So x plus h, right? Living my best life. All right. Okay, so let's expand it out. If we expand it, we get this plus this, right? So nothing. It looks like there are no like terms. Nothing simplifies. Nothing combines. So we let that be. So now we're going to go. So this is the first thing for difference quotient. The second thing we're going to do is to focus on the numerator. So we're going to do this f of x plus h minus f of x, right? So that's going to be basically all the stuff that we just got, or all of this. And then we're going to say minus f of x. So we need to distribute that negative. X squared plus 9. Again, we need to distribute this negative. Right? If we distribute the negative, the following happens. The first part stays the same. Then the second part becomes minus x squared minus 9. Right? So then we get some cancellations going on. This cancels this. This cancels this. And what we're left with is 2xh plus h squared, right? So that's the numerator simplified. The final step is we're going to say basically the whole thing. F of x plus h minus f of x all divided by h. So we're going to take that answer that we got, this 2xh plus h squared, we're going to divide by h. Okay. So then on the numerator, there's a GCF. We can factor out an h from both of those, and we're going to have this 2x plus h divided by h, and then we got some cancellations going on. So then the final result that we get is 2x plus h. Okay. Let me check this answer first before 2x plus h. Let's do like this. We're going to hop back to Pearson. The difference quotient, we got 2x plus h. Not h. Okay, we'll go on to the next question, and before I finish the next question, let's go ahead and keep those in. Okay, we got together. Now I probably got to close that for the work properly. I'm gonna go ahead and let them in, and let me think about this one. So, oh, it's a constant function, right? So the y values, right? So, okay, if we look at this, right? No matter what x we choose, y is always 1, right? So even if we plug in f of x plus h, the answer is still going to be 1. So the top is going to be 1 minus 1 divided by h. Ultimately, that the difference quotient there is going to be 0. Because no matter what x value we choose, the answer is always going to be 1. So the top is going to be 1 minus 1 divided by h. That final answer should be 0. Hopefully that makes sense. It was a little bit fast. Okay. Let's do the next one. Let me check the chat real quick to see if there are any requests. So the exam is going to be the second half of chapter 1, but keep in mind that mathematics kind of by default is cumulative, right? Like you can't really do the second half of chapter 1 without being comfortable with the first half of chapter 1. But you can anticipate the questions coming from the second half, but we're still going to use things from the first half, right? That's just the nature of mathematics. Right? I'm always tired. I don't be sleeping. I be up. I just when I get sleepy, I go to sleep usually, unless I have to teach. Then you know. But when I wake up, I just go ahead and get up. I stopped trying to force myself. That was torture. Trying to force myself to sleep through the night. I was like, nope, I'm up. I'll get up and I'll mind my business. And then when I'm tired, I'll sleep as long as I can. And then what happens is I have to take naps during the day, but I don't know. Okay, it says the graph to the right shows a particle movement on a coordinate line with a velocity v equals f of t at a time t seconds. Find the domain and interpret, right? It's just a particle moving on a coordinate line with a velocity. Let me think about it. T and the velocity. So the time versus the velocity. The domain. So how long the particle was moving, right? What's the domain of this function? It looks like the domain goes from 0 to... It goes from 0... What is this? 16, 17, 18, 19, 20, so 21, 22. 22 seconds, all right? Type in interval 0 to 22. Let's see. Let's do square brackets. We're going to do from 0 to 22 seconds. Interpret the domain. The particle's motion is tracked indefinitely. No. From time 0 to 22. Yep. Particle tracks on all. No. No. We're just going to go B, right? Let's go B. So long that makes sense. Oh, that was it. Okay. What was this? Oh, we're almost done, so we're going to probably backtrack. Table below shows a recent state income tax schedule for individuals filing a return. Okay. Write a piecewise definition for the tax due on an income of X dollars. Let's see. So 0 to 15. If taxable income is between 0 and 15,000, the tax due is 2.5% of the taxable income. So if we want to add 2.5%, instead of saying 100%, let me see. The tax due, so the amount due, so just 2.5% of our taxable income. So I'm going to do 0.025x. I'm going to go with that. Oh, we need to do the other part. And then if the income is between 15,000 and 30, it's this plus 6% of excess over 15,000. So the amount over 15,000, we can say x minus 15,000. So for this one, I'll do x minus 15,000. So that gives us the amount that's over 15,000. And then we want to take 6% of that, or we want to say 0.0615 times this thing plus 375. I think this is okay. So if we were to simplify 6.15% of 15,000, basically I'm distributing the 6.15%. Hey Google, what's 6.15% of 15,000?
6.15% of 15,000 is 922.5.
Okay, so we distributed that percentage. I think this is okay. Then we want to combine like terms. Let's see. Hey Google, what's negative 922.5 plus 375? think we were missing one thing. Because remember, we distributed that 67%. I mean, 6.7%. So it needs to be here next to this guy. I think we did that properly. Let's try the next one. Let's keep going. We'll come back and fix it if we get it wrong. This, so the taxable income is going to basically the same formula, but instead of 6.15. Okay. So we're going to do basically what we're doing. We're saying whatever the income, the taxable income is, minus 30,000, sorry. Minus 30, 1, 2, 3. 6% of whatever that difference is, 6.7%. So we're going to say 0. Hopefully I'm doing. Nope. Right here. This needs to be 615. I'm probably going to go back and redo that one because I'm not sure if I use the 6.7 or the 615. But this one's supposed to be 67. 30,000 plus 1297.50. Okay, let me crunch some of these numbers. So this can go 6.7. Hey Google, what's 6.7% of 30,000? Hey Google, what's negative 2010 plus 1,297.5? Hey Google, what's 2010 minus 1297.5? Let me see if Siri can do it. Hey Siri, what's negative 2010 plus 1,297.5?
Negative 2010 plus 1,297.5 is negative 712.5.
And I think that this is after us combining all these like terms, all this can go. Let me go back and check this other one. Let me just redo the second one. Okay. Excess over 15,000. So we said X minus 15,000. We distributed the 6.15%. So this is 0.0615. 6.15%. And we added the 375. 6.15. Hey Google, what's 6.15% of 15,000? Hey Google, what's 922.5 minus 375? Okay. And then all of this can go. Okay. I feel better about this. I just went back. I think this is what we had before, but I just went back and recrunched the numbers to make sure that we did it proper. Okay. Let's see how do we do. Can we zoom out some? No. I should have just hit enter. I think I erased whatever we just did. I'm trying to see if I can get it to come back on some level. Zoom. Alright. That was fun. But let's preview. I think we can do it quickly. Yeah, I think we were on 23. Nope. 22. Okay. It's probably different. It is different. Okay, let's just do it one more time. Full screen, and let's change the view before we do stuff. Go like this. There it is. Okay. That was fun. All right. 3% of taxable income. So this one is just 0.03x. All right. I don't know why the font is so big. Let me see if I do it like this. That helps. Okay, that's better. And then the next one Okay. Excess over 15,000, so we're going to say X minus 15,000, 5.5%. So we're going to multiply that by 0.055, 5.5%, and we got to save the 450. We got to add 450 to whatever the answer is. So, okay. I'll come back and simplify that momentarily. I'm going to go ahead and do this one. So this one is the 0.0675 times x minus 30, 1, 2, 3, plus this 1275. Okay, let's crunch these, let's simplify these down. If we distribute that 5.5%, hey Google, what's 5.5% of 15,000? Okay, when we distribute, we got that 825. Hey Google, what's 825 minus 450? Hey Siri, what's negative 825 plus 450?
Negative 825 plus 450 is negative 375.
Thank you, Google. 30 minutes later, she got jealous because she saw me go into Siri. She's like, "Oh, let me answer before he started going to Siri." All right, if we distribute this 6.75%, hey Google, what's 6.75% of 30,000? 2025. Okay. Hey Google, what's 2025 minus 1,275? Okay, let's go with it. Okay. That was an adventure. Okay. Hopefully we worked out the kinks. Let's cross our fingers. Phantasm. I would be devastated if I got that wrong. Because that was a lot of work. Not really a lot of work, but it was work, right? And, you know, if you do all that and then it's wrong, you're like, oh, what did I do wrong? You know, come on. Anyway, okay, let me see the time. We get out at 6:30. Ooh, I am fading. All right, let's keep it rolling. So let's go. So again, I started the intent with the technique for today. I'm intentionally choosing questions that I did not work with my other students. So if you want to see like the earlier questions, you have to look at my videos from earlier today. I did two of them, so for two different parts of this same section. So that way, as a collective, all three videos together give you pretty much all of these questions for this section. Right? This section was just a little bit more involved than others, you know. So I decided to do it that way. Determine the graph of this function, right? So when x is between 0 and 15, that's just going to be some positive slope or diagonal. This is going to have the slopes are getting more and more steep. And then we have our y-intercepts. So let me see. Like this one looked like it kind of did not behave properly. See if I can just do a quick eyeball. These all look very similar. So then let's choose some test points. When x is 15,000, whatever 3% of 15,000 is. Let me see. Hey Google, what's 3% of 15,000? 450. So when x is 15,000, it should be 450. See, if that's 220, this could be 450. It's just below 500. 15,000 is definitely not B. That's way too high. It's not D because that's not 450. That's like 6 or 750. That's like 600 or 700, something like that. 15,000, 450. If this is 250, 35, it could be this one. So let's choose another. It's either A or C. Let's choose another one to test. So 15,000. Let's do when X is 30,000. When X is 30, whatever this number is. 5.5% of 30 minus 375. Hey Google, what's 5.5% of 30,000 minus 375?
The answer is 1,275.
1,275. Right here's 30, 1,200. It could be this one. 30, 275. I think this one's too low, right? Because if the halfway mark is 1250, and this is below the halfway mark, 1250, right? I'm going to go with A. That's the one where the numbers seem to be the closest. Let's just go with it. Okay. All right. Let's see. What else do we got? Find the tax due on an income of 12,000. This thing, right? So that's just 3% of that. Hey Siri, what's 3% of 12,322?
3% times 12,322 is 369.66.
Oh, that was it. Oh, I'm sad. I was just gearing up for like if we got one of those larger ones. Okay, let me check the chat. Let's check the chat. Okay, so nothing, no questions there. Let's go on to the next question. So again, to get all the questions that we did today, you'd have to use all three of my videos from today. All right. I'll be right back. Be right back, guys. Ooh. Oh, you just chilling like a villain, huh? All right. Let's keep moving. All right. So it says Kara's custom tees experience fixed costs of $400 and variable costs of $2 a shirt. Write an equation that can be used to determine the total expenses encountered by Kara's custom tees. Let X be the number of shirts and let C of X be the cost of producing X shirts. Then calculate the cost of producing 5. A fixed cost of $400 and a variable cost of $2 a shirt. Okay, so we're just determining a cost function, right? Okay. Total cost of producing X shirts. Oh no, my bad. It says the fixed cost, right? So just to go into business, she has to ante up $400. But then it costs her $2 per shirt. So for each shirt, it's going to be basically 2 times each shirt, plus that $400 startup fee. So for instance, like if she sells, just to get started in the business, even if she doesn't sell a shirt, she has to. So if X is 0, she still comes out of pocket $400. If she creates one shirt, it's the $400 plus the $2 for the one shirt. If it's 2, then it's going to be $400 plus the $4, right? So this function, I feel okay with this. I'm just going to go with that. Okay. The cost of producing 5 shirts, right? 5 times 2 is 10, so $410. Okay. Is that it? Oh, that's so sad. Okay. Let me check the chat, and I'll probably just kind of go back. So let's kind of see if I can find some interesting ones. I don't think I want to leave from section 1.4 today. I'm gonna just kind of stay in section 1.4. So let's go ahead and do this one. We'll just start back from the beginning. So this one asks us to write a linear function that has an indicated value and sketch the graph, right? A linear function. So we want the equation of the line through these points. Okay, so let me take some notes. So this is question number 1. It comes from section 1.4, question 1. And we're given that what f of 0 is 2 and f of negative 2 is 0. Right? hop over like this. Show this thing. Okay. So we want the equation of the line through those points. So I'm going to use. I'm a fan of using y equals mx plus b. Okay. So we have a set of ordered pairs. This says that when x is 0, y is 2. When x is negative 2, y is 0. Okay. So it might be a good idea to find the slope between these points, all right? So the slope formula, y2 minus y1 over x2 minus x1. And just for good measure, the third equation of a line that we use is y minus y1 equals m times x minus x1, right? So I want to find the slope. So let's find the slope. y2 minus y1 over x2 minus x1. And usually when I get ordered pairs, I just automatically label them x1, y1, x2, y2, right? So that's going to be what? 0 minus 2 over negative 2 minus 0, negative 2 over negative 2, which is a positive 1. And then the y-intercept is when x is 0, so that means our b is 2, and our m is 1. So then the equation of our line could be y equals x plus 2. Or maybe not y, but f of x. Okay. And then we can check, right? When x is 0, y is 2. When x is negative 2, y is 0. So let's try this one. So we got what? X plus 2. All right. Oh, so this is a line. It's just a regular diagonal line that's been moved up by 2. It's this one. Let me see if there are any requests from this section. Okay, that's the time. I guess we can do this one because I know I skipped this one. My other one. This one's worked in a similar fashion. Sketch the graph. Okay, it's essentially the same thing, right? Just with different numbers. So this will be number 2. This comes from section 145. Linear function. So we're given f of negative 1 equals 3, and f of 3 equals 11. Okay. So over here, like this. So that means when x is negative 1, y is 3. When x is 3, y is 11. Let's start off with the slope formula. y2 minus y1 over x2 minus x1. And again, x1, y1, x2, y2. y2 is 11 minus 3 over 3 minus a negative 1. That's not a negative 1. Let's do one more. Negative 1. Okay. There's an 8 divided by 4, which is 2. So then I'm going to use y equals mx plus b. So I'm going to use this. I'm going to use the first one because the numbers seem like they're more simple. So when y is 3, the slope is 2, and our x is negative 1. Only thing we don't know is b. So if we add 2 to both sides, b equals 5. So then we can say y equals the slope 2x plus 5. Okay, and instead of y equals, we'll do f of x. Okay. Let's check. So when x is -1, that's 3. When x is 3, we get 11, right? So we got 2x plus 5. Here, 2x plus 5. Okay, thank you. So the y-intercept is 5. It has a positive slope. This one is promising. This one, the y-intercept is too low. So I'm just going to go with A. The other two have a negative slope. Okay, let me check the chat. Okay, that looks good. I'm going to go into the next question. Find the intervals over which the given function is increasing, decreasing, or constant. So this is going to be a line with a positive slope, so it's going to be increasing over its entire domain, and it's never decreasing. This one. Increasing, the domain is going to be all reals. So negative infinity to infinity. It's never constant, so that's going to be B. Okay. Given function is increasing, decreasing, constant. Okay, so this is going to be a parabola that's opening downward, right? We didn't move it left to right, nor did we move it up and down. So it's increasing. So as we trace it left to right, it's going to be increasing first from negative infinity to 0. And then the next one is going to be decreasing from 0 to infinity. And I'm just kind of visualizing this graph. Again, it's just a U-shaped graph that opens down, but we didn't move it left to right nor up and down. We just did a vertical stretch by a factor of 2. Constant is never constant, right? So we're going to go A. Okay. Let me check the chat. Okay, let's keep it moving. So I yawn. The dog looks at me and she does this like the cutest yawn ever. She does a yawn too. Then she got her paws like one on top of the other, and it's like she be knowing that I be talking about it because she looks directly at me. I'll never use her name, but she knows I'm talking about her. She's just looking at me like, yeah, why are you talking about me? Okay, let me kind of give an explanation on this one. This is number 5. So number 5, I did a screenshot earlier. Yeah, let me screenshot. So let's go like this. Here. Here. And I'm going to share. Let's go here. I want to add photo. Nope. Cancel. That's all I'm trying to do. This one. You doing that thing here? Okay. Come on. This one. Okay. Let's add a photo. We want this one. Add. Awesome. Living my best life. Okay. Oh, and then let's hop over to the tablet. Oh, wait, don't do it there. Hop over to the tablet. Okay. So let's recap the definitions of even, odd, and neither. Okay. In this context. So again, formal definition of what it means for a function to be even. If we do f of negative x, we get back the original. Right. The definition of a function being odd. If we do f of negative x, we get negative of the original. Right. Even is the same as y-axis symmetry. Also, another way to view it is whenever we have x comma y, we also have negative x comma y, right? For odd is the same as origin symmetry. Origin symmetry. So with origin symmetry, whenever we have x comma y, we also have negative x comma negative y. Okay. So then if we look at these numbers, notice the first order pair we have negative 100 comma 85, but we also have 100 comma negative 85. Right? So is this similar to the even case or the odd case? Right? Let's do another one. We have the order pair negative 10 comma negative 10, and we also have the order pair 10 comma 10. Right? So notice both the x and the y's are changing. They're both changing. So that means that this should be an odd function. So I'm going to go with C. Let me hop back over to Pearson. So I'm going to go odd. And again, all the stuff you see me writing, I'm going to make it available for everybody. Let me see. So the x's changed, and they both changed there. They both changed here. They both changed, so that's going to be odd. Okay. I think we did this one, but let's do it anyway. So we're asked to determine algebraically if this function is even, odd, or neither. So this is what, number 7? So this is question number 7. It comes from 1.4, question 25. I'm going to say, is it even, odd, or neither? Okay, and we have this, we're given this g of x equals 9x cubed minus 3, right? I'm going to top over to the tablets. This one. Okay. So again, to do a test for even or odd, first we're going to rewrite the function, and we're going to replace each x with negative x. So first I'm going to start by replacing each x with a blank set of parentheses. And then into the blank parentheses, we're going to put negative x. Right? So then if we simplify, this is going to be negative 9x cubed minus 3. I think even if we factor out a negative, we can't get back to the original in any form. So then I'm going to say that this is neither. Okay, neither. So let's hop back over to Pearson. Let's go with this one. All right. Let me check the chat. Determine if the function is even, odd, or neither. This one, if we replace the x's with negative, I think this one is going to be odd. I'm just going to go with odd. Okay. Because if we factor out the negative, we should get negative of the original. I'll work with that one if you need me to. Let me work with this one. So this is number 9. All right, let's go to question number 9. I just realized that. Oh, I don't know. I'm going to just go here. I think it'll be fine. I'll be in the system. And this comes from section 1433. They want to know if it's even, odd, or neither. Even, odd, or neither. And f of x is going to be, now the numerator is going to be x squared minus 9x. The denominator is going to be 6x to the 4 plus 7, like this, right? And let's go like this. And let's show what we're doing. Okay. So again, even, odd, or neither We're replacing all the x's with negative x. So first I'm going to rewrite my function. First thing I'm going to do is replace all the x's with blank parentheses. Okay. And then into the blank parentheses, again, to test for even, odd, or neither, we're going to put negative x. Okay. So then that's going to be x squared plus 9x over 6x to the 4 plus 7. Okay. Now, I think even if we factor out a negative, it's mainly this guy right here is why we can't get back to the original. If this were a negative, then, we could get back to the original. But because of that one sign, we cannot. So this one is going to be neither. That is gorgeous. Okay, neither. Let's hop over to Pearson and see how do we do. Okay, so we're saying it's this one. So it says the graph of a function is given to the right. Use the graph to find each of the following. Okay, what is the domain of the function? What the heck is that? Is that a mosquito? I hate when mosquitoes get in the house. I don't even know where it came from. Like something big, and it just disappeared. Like it was something, I saw it coming, I was like, what is that? And then it brushed me. Oh, there it is. I'm gonna get him. Let me think. I want to get him soon too. I don't know where he came from. Like nobody's come and gone. Ugh, I hate that. Cause then it's gonna try to eat me. It's gonna either eat me or the dog. I don't have to trap him. Gotta think about how to trap mosquitoes. I know I could use the fan. Yeah, I still have like 15, about 15 minutes. Yeah. Okay, I'll get it later. Hey Google, turn the fan on. It's just what I need. Don't need that thing munching on me. I can't stand those things. Like I go out of my way to keep them out of the house. Okay, what is the domain of the function? Okay, so let's look at the graph. So the domain is the very left to the very right. The far left is going to be x is negative 3. The far right is x is 9. So it goes from negative 3 to 9. I'm going to do square brackets going from negative 3 to 9. The range is the very bottom to the very top. Heck, and I think he got me too. Ugh, hate mosquitoes. No, hate is an accurate word. It's not a strong word. It's accurate. That's how I feel about it. I know that I know they have their purpose, but I think I'll be fine without mosquitoes. Like, we'll figure out a way to get whatever needs to be done. All right, so the range, the very bottom, right? The lowest y value is negative 3. The highest y value is 3. So we're going to go from negative 3 to 3. So negative 3 to 3. All right. X-Intercepts. I think we had to actually calculate this one, right? Because it's not clear. I don't think we should guess it. We're just going to go ahead and calculate those based on the information given. So let's take some notes. I know there's a chat. I'm going to just finish this one out, then I'll look at the chat. So this is question number 10. Ugh, goodness. Damn. Like, it just blows my mind how I can't feel them. And they're like so deliberate, so soft. It's so irritating. Now I'm starting to itch. Damn, it just came out of nowhere. Like, how have we been here all this time and then all of a sudden the mosquito gets in here. Damn. Okay. So we have this ordered pair, right? We're trying to find the x and y intercept. So what I'm going to do is find the equation of the line through these 2 points, right? This comes from section 1-4, question 35. And I want to find the equation of the line through the ordered pair 4, 3, and the other one is -3, -3. Okay? So let's hop over to the tablet so I can show what I'm doing. Okay? I don't even know how he got me. Because I'm looking for him. He got me twice. I'm like, and it's like I'm sitting right here. Like, I don't know how he did that. And it's like you can't feel anything until it's too late. You're like, no. And so now I'm trying not to scratch them because if I can go about 20 minutes without scratching them, then they won't bother me anymore. Like, it'll go away, it'll heal, won't leave a scar. It's just a matter of not scratching them for 20 minutes. If I really got to scratch it, though, you can take like a piece of ice and rub a piece of ice on it, and it'll soothe the itch without irritating the skin. So like if push come to shove, I'll go get a piece of ice or something cold. But I'm more concerned with like just finding him so I can get him out of here. I might have to like make a lure or a trap. There are traps you can make to catch like flying insects that get in the house. Is the door open? Hang on, I'll be right back. Hang on, guys. Yeah, I'm gonna just have to find him. This is gonna, I'm not gonna. It's gonna be kind of like until I can find him. I'll get him. Anyway, all right. So we want to find the equation of the line through these 2 points. All right. So again, I usually like to go x1, y1, x2, y2. Let's go ahead and find the slope first. Y2 minus y1 over x2 minus x1. All right. Let's kind of realign this a bit. So then we're going to do -3. Oops. We're going to do -3 minus 3 over -3 minus 4. Right? That's going to be -6 over -7, which is 6 by 7. Okay? Yeah, how did he do that? Okay. So we got our slope. Now we want to find the y-intercept. So I'm going to use the slope-intercept form. I'm going to start with y equals mx plus b. Let me see. I'm going to choose the first point because they just don't have no negatives. So I'm going to say when y is 3 and the slope is 6 by 7 and x is 4, the only thing we don't know is b. So then ultimately b is going to be 3 minus 24 over 7. You can use a calculator here. I'm just attempting to do it by hand. 21 over 7 minus 24 over 7 is, what is that, -3 over 7. Right, so the equation of the line is going to be y equals 6 over 7x minus 3 over 7. Okay, let's go back and answer the question. I don't need that box. Let's hop over to Pearson. So this question asks the x-intercepts, so that's when y is 0. Okay, so if we set y equal to 0 and solve, 7, I think it's a half. Okay, let's go back. Let me write it out. So let's go here. Oh no. Woo! got close. Oh, darn it. Let me see. Yep. Now I gotta try to. Can I just go back? Okay, let me close this out. Darn it. Let me preview. What's the time? That mosquito really got me thrown off. Like now I'm like trying to find him and catch him. I don't know where it came from. We were working on question number 10, and I'm pretty sure the numbers are going to change. Yeah, the numbers will change. Okay. I mean, I'll go ahead and redo it. So I accidentally hit the wrong button, so we were not able to finish the one that we were working on. So let me just kind of quickly get back. What's the domain from -1 to 8? Square bracket, -1 to 8. The range is -1 to 3. X-intercepts are we need to calculate, right? So I'll just say this is number 10 alternative, right? So ordered pair in this case, we got -1, and 4, 3. Okay, let's go ahead and label. Let me hop over to the tablet. Like this. X1, Y1, X2, Y2. So then Y2 minus Y1 over X2 minus X1. That's going to be our slope. So that's going to be 3 minus a -1. Oh. He's still like trying to feast. He's like keep buzzing in my ear. He got me twice on one arm, right in front of my face and head. Sometimes I can feel him, but I can't catch him. I turned the fans on to because they're weak. They have weak flyers. So if you have air moving, it's harder for him to land on you and bother you. I probably should turn the fan this way to blow him away. But anyway, 3 minus a -1, and then 4 minus -1. And I've been sitting here for hours. I'm like, how did that mosquito get in here? And he just started like a few minutes ago, out of nowhere. That's gonna be a 4 over 5, right? So then we want to go back and find our Y-intercept. So I'm going to use Y equals mx plus b. Okay. Let's use the second point. When y is 3 and our slope is 4 by 5, our x is 4. Only thing we don't know is b. Ooh. So then b is going to be 3 minus 16 over 5. It's going to be 15 over 5 minus 16 over 5, which is -1 by 5. So then the equation of the line is going to be y equals the slope, which is 4 by 5, x minus 1 by 5. Oh, it's like, oh, hate mosquitoes, especially when they get in the house. I can kind of tolerate it when they're outside because I was like, okay, I'm kind of coming into your space. Don't come into my house. That's so disrespectful. Biting me in my house, irritated me. And it just came out of nowhere. Like, I still don't know because, like, I haven't moved. I've just been sitting here for, like, I've been sitting here since about 2. And it's now 6. Like, for 4 hours, you just waited to kind of torture me up until now. Anyway, now let's go back and answer the question. They said the X-intercept, right? To find the X-intercept, we set y to 0. So, again, for the X-intercept, we set y equal to 0, right? If we set y equal to 0, we're going to have 0 equals 4 by 5 x minus 1 by 5. I see the time. I'm going to multiply both sides by 5. So I'm going to say this times 5, this times 5, and this times 5, right? These are going to cancel. And that essentially goes to 0. So on the left, we still have 0. On the right, we now have 4x minus 1. So then x equals 1 by 4. Okay? So the x-intercept is going to be 1 by 4. Let me hop back over like this. And then next, let's go like this. So the x-intercept in this case should be, we got a positive 1 by 4. Okay. The y-intercept, so set x to 0, we're going to get a negative 1 by 5. And this is why I was like, we need to calculate these because we can't really eyeball it. You know, we needed to come up with an algebraic way to find these numbers instead of trying to eyeball the image. Increasing, okay, so it's increasing as x goes from negative 1 to 4. I want to use parentheses. Negative 1 to 4. Ooh, I think it got me again. God, I'm gonna get him. I think that somebody may have come in and let him in. I'm pretty sure they were sitting with the door open. All right. Let's continue. Decreasing. It's never decreasing, so we're going to choose B. And then continue. Constant. It's constant as x goes from 4 to 8. I'm going to do the open interval. X goes from 4 to 8. All right. There's no symmetry. There's no y-axis, nor is there origin symmetry, so I'm going to do neither there, and that's it. Okay, guys. We're going to go ahead and stop here. I'll check the chat one last time to see if anybody had any questions. Oh, that's probably the soothe. I'll look into it. But right now, I just want to make sure we get him out of here. Like, I don't want him in here. I hate having mosquitoes where I sleep, because then they'll eat you when you're asleep, and it'll be bad. Anyway, I think he, like, teleported. Anyway, all right, guys, enjoy the rest of your day. Well, same place, same time on Thursday. We'll be back on Thursday. Okay, guys? All right, thanks for being awesome. Take care. See you next time.